Imagine a grand hotel with an infinite number of rooms and an infinite number of guests in those rooms. On this particular night, the hotel is completely full. You arrive at the hotel late at night and ask about the bed. Despite the fact that there is no vacancy, the hotel manager assures you that since this is an infinite hotel, she can easily make space for you. You're overjoyed but perplexed. How would the manager go about securing a room for you if the infinite hotel is absolutely full with an infinite number of guests? That was the idea of German mathematician David Hilbert, friend of Albert Einstein and enemy of chambermaids the world over. To challenge our ideas about infinity, he asked, what happens if someone new comes along looking for a place to stay? Hilbert's answer is to make each guest shift along one room. The guest in room 1 moves to room 2, and so on. So the new guest would have a space in room 1. And the guest book would have an infinite number of complaints. But what about when a coach containing an infinite number of new guests pulls up? Surely he can't accommodate all of them. Or can he? An infinitely large bus with an infinitely large number of passengers pulls up to reserve spaces. The key phrase is countably infinite. The night manager is initially perplexed by the infinite bus of infinite passengers, but he soon discovers that there's a way to position each new individual. He demands the guest in room 1 move to room 2. He then requests that the guest in room 2 relocate to room 4, the guest in room 3 relocate to room 6, and so on. Current guests transfer from room N to room 2N, filling only the infinite even-numbered spaces, which are the hotel rooms. He has now cleared all of the infinitely many odd-numbered spaces, which are then occupied by the people filling off the infinite bus. Everyone is happy and the hotel's business is expanding more than ever. But what if there's an infinite number of buses, all filled with an infinite number of room-seeking guests? So, in order to complete the nearly impossible task of finding infinite beds for infinite buses of infinite exhausted passengers, the night manager assigns each current guest to the first prime number, 2, raised to the power of their current room number. As a result, the existing occupant of room number 7 is transferred to room number 2 to the power 7, which is room 128. The night manager then transports the passengers on the first of the infinite buses and assigns them to the room number of the next prime, 3, raised to the power of their bus seat number. So the person in seat 7 on the first bus goes to room 3 to the power 7, or room 2187. This continues for the duration of the first bus. The passengers on the second bus are given powers of the next prime, 5, and the passengers on the bus after that, powers of 7. Each bus is numbered as follows: powers of 11, powers of 13, powers of 17, and so on. There are no overlapping room numbers because each of these numbers has only 1 and the natural number powers of their prime number base as factors. All of the bus's passengers are divided into rooms using unique room assignment schemes based on unique prime numbers. As a result, the night manager can accommodate an infinite number of passengers in the infinite number of buses.